So I told you today we were going to do 9.3. We're actually going to be moving on to just 9.4. 9.3 just talks, and I can quickly talk about it. When you have a square root and inside you have an x plus 4, remember inside is going to move it right and left, so that's actually going to move it in the opposite way, I think. So it's going to move it left 4. If I had square root of x plus 4, this is going to move it up and down. So we've already covered those translations pretty good, so I'm going to skip it because we're a little bit behind. You can look through that, but that's basically all it's talking about. When you have a 2 out here, that would be a vertical stretch. If it was a half out there, it would be a vertical compression. All those same rules that we've talked about still apply. So they would just help you to graph the x and y chart. The x, square root of x would be the parent function. And remember, x has to be greater than or equal to 0 for these. Because you can't have a negative under square root. Be graphing that because it won't be a real number. So we're going to move on to 9.4. Problem 2 we're going to move to real quick. And these are just basic rules. If you have a to the n, and this is hard to read, but if you have, it should be in your book, a to the m times a to the n, all you have to do is you can make this a to the m plus n. So if I have 2 to the second, and I times it by 2 to the third, it becomes 2 to the fifth. You just add these guys together. If you have division, what it becomes is a to the m minus n. But remember how I did it is whichever one's bigger, you cancel out. So if I had like x to the fourth over x to the second, this becomes x to the second because this is gone. I cancel 2 of these out. I'm left with 2, and this becomes a 1. X squared over 1 is just x squared. If I had x squared over x to the fourth, these completely go away. 2 of these are left. That's over 1, so final answer is 1 over x squared. Either way, just remember those rules. If you have a power to a power, then you multiply them. So this becomes, so if I had like 2 to the second to the third, that actually becomes 2 to the sixth. Now here, this is a huge thing that we need to remember. Please, please, please be careful. With this guy, there is a multiplication sign in the middle, and then you can just distribute what is out there. So if you have a to the fourth, b to the second, and you have all of that to the third power, you can distribute this. If you had a to the fourth plus b to the second, and you take that to the third power, you cannot distribute this 3. This having a plus sign is totally different than this problem down here, so please remember that. Same thing if you have division, you can, if you have a to the fourth over b to the second, and you have all this to the third power, you can distribute this 3 to the powers like that, and that becomes a to the 12th over b to the 6th. And these guys cannot cancel each other out because they're not like terms. Just remember this from last chapter. Anything to the 0 power is 1, as long as you don't have 0 to the 0 power. We won't have that case pop up today, but if you have anything to the negative power, so if I have x to the negative third power, that really is equivalent to 1 over x to the third. Wherever this is touching the negative, it just sends it to the opposite location. So since this is in the top, it sends it to the bottom, or the numerator to the denominator. Now if I had x to negative 3y squared, then this becomes y squared over x to the third. Remember, you only send down what is touching the negative. This y squared is still on the top, so that's why it stayed in my top. And just like the on contrary, if you have x to the negative 2 and it's in the denominator, and you had y to the second, then this would become x squared y squared, because when you have the negative here, it sends it up. So remember, we have a negative exponent, it just moves it to the opposite location, either up or down. That's kind of how I remember it. So those are some rules just to make sure that we go over. We're going to be using those kind of rules when we attack these problems coming up. All right. So here's something that we can happen. We're going to talk about how to change something from power form, and actually I'm just going to teach you the way that I do it, and then we'll talk about why it works. But if you have x and it's square root of x, the number that is out here is a 2. The number of the power here is 1. Even though those aren't written, I know those are there. And what happens is it becomes x to the negative 1/2. This is, or 1/2, sorry. This is changing from radical form into power form. And what happens is the 2 becomes the denominator over here, and the 1 became the numerator over there. Now the way that that works is, if you think about it right here, if you have the square root of x, and you want to say, what does that equal? What to the what power is that? So we're actually solving for a. I know x is a variable, but this is going to be any number, so it could be a 2, it could be a 3, but we're going to solve what would that be equivalent to. So how do you undo square rooting something? You square it. But if I square that side, I have to square this side, and so what you end up with is x equals x to the 2a power, because remember, a power to a power, you multiply them, so that's how they got 2a. Well, then when they get right here, if I have 3 to the 2nd power, and I say that equals 3 to the x power, hopefully you realize when you have 3 here, and you have 3 here, once you have the base the same, that means the exponents have to be equivalent. So I know that this would be, my x would have to equal 2. And so since I know this has to be equivalent, right here I have x to the 1st power. So I have an x and I have an x, so the base are the same. That means my exponents have to be the same. That means that 1 has to be equivalent to 2a. So 1 equals 2a. You divide by 2, you realize that a equals 1/2. That's where they got this from. But the way that I do it is just like I said. All you do is the power that's in here becomes the numerator, the number out here becomes the denominator. So if I had the cube root of x to the 2nd power, that would become x to the 2/3 power. There are restrictions for these, for the, why was it given that x has to be greater than 0, because when you take this square root, remember x can't be a negative. When you have this, x has to be bigger than 0, because once I get to the negative side, I start having imaginary numbers, and we're not dealing with those anymore. Thank goodness for some of you. Alright, so if it says this, it says take the cube root of x turned into its power form. Well, the power here is 1. That becomes my numerator. This becomes my denominator. You can write it like this. No need to spend too much more time. So you can fill in this chart. In fact, I would go ahead and do that just to make sure you understand this. I can try to make this a little more legible. That's x to the 2/4, x to the 3/4, x to 2/5, x to 1/5, and so on. Alright. So rewriting, extracting roots, rewriting radicals, and using radicals or powers to solve equations. So we're going to go through this 2 different ways. One way you can do is if they give me the problem, and the problem says, so my original problem is the cube root of 8x to the 6th power. I can solve this using radicals, which means I can just simplify this. Think about this in terms of square roots. If I have, so the way I teach my students is when I have like the square root of 16, what this really is you can rewrite this as the square root of 4 squared. And every time you have a pair in there, you get to pull one of these base numbers out. So you get to pull a 4 out. All right? So if I had something like the square root of 4 to the 5th, x to the 7th, y to the 8th, every time, and we're going to talk about something new here. I'm just going to do this just pulling out part real quick. This is a little 2, so I need to, and in order to pull something out, I have to have a pair. So how many pairs do I have? When I have 4 to the 5th, I have 2 pairs. That means I get to pull 4 squared out. How many pairs do I get when I have a 7? I have 3 pairs, so I get to pull x to the 3rd out. And there's 1 left over here, because that only takes me 2. When I pull 2 pairs out, that gets me 4. Well, there's 5, so I have 1 left over. I pulled out 3 pairs here. Well, that leaves 1 in there. I'm going to pull out 4 pairs of the y, and that's going to be completely gone. So I used all of them. So in left, I'm going to have 4x. And like, there's going to be something else we're going to talk about with this power right here. This actually has to be an absolute value. But we'll talk about that in a little bit. So that same rules are going to apply for right here. So what I need to know is I need to break these down. So I always taught my kids to use your factoring, your factor tree. So what this is this is 4 times 2. There's my prime number. So this is 2 times 2 times 2. So always write these numbers as their prime factors. That will tell you what you can pull out. So it becomes 3, 2 to the 3rd power, x to the 6. I need 3 of them in order to pull 1 out this time. Over here, it was only squared, so I needed 2 of them in order to pull 1 out. Well, I need 3 for this one, so I have 3 2s, so I get to pull a 2 out. Well, here I have 6 x's, so I need 3 in order to pull 1 out. Well, I can pull out 2 x's because 2 times 3 is 6. So I can pull, there's an x to the 3rd and another x to the 3rd. So I get to pull 1, 2 of these guys out. So that's how they use doing radicals. That's where they got this answer from right here. Using powers, what they do is they say, you know what? This is 8x to the 6. And if I change the 3rd, right, this is 8x to the 6. The whole power of this thing, if I take this whole number, is 1. And then that becomes 1 over 3. Because remember, Mr. Martin said whatever the power is here goes on the top. Whatever this is on the outside. Remember, they did the power of the whole thing as a 1. And then what happens is when we had this power to a power, and since this is multiplication here, you can distribute the 1/3, and this becomes 8 to the 1/3, and x. What happens when you multiply fractions? It becomes 6 over 3, or just a 2, because top times top and bottom times bottom. 8 to the 1/3, you could put that in a calculator, or you could realize that that just means the cube root of 8, which is 2, x is second. A bunch of different ways that you can think through that. So either way, you can solve these problems kind of doing that, using radicals or using the powers. So you should be able to read through this. Now be careful, there is one rule that you need to know. When you have a even power, and you pull out an odd power, so if you pulled out an even power and you pulled out x to an odd, you must put absolute value signs around that. And that's because when you have an even power, you're not allowed to have a number that's under here that is negative. And so when you have this being a negative, we would get an imaginary number. So when I pull it out, I can't have a negative out here. So I've got to counteract that because something to an odd power could turn negative. Let's try to see if I can make an example of that. If I had 4th power of x to the 12th. That says that this should be x to the 3rd. Right? If I don't put my absolute values in here, and I say, what if x equals -3? Well, here, if I put a -3 in, right? As soon as I put -3 and I take it to the 12th power, I'm going to end up with a positive number. I'm going to take that positive number and take the 4th root of it, and so I'm going to kick out a positive number. I don't care what that number is right now. That's not what my example is going to be showing you. But if I take this, and I take this -3, and I put it in right here, that means that I'm taking -3 to the 3rd power. Well, -3 times a -3 is a positive 9, but a positive 9 times a -3 is a -27. It equals a negative number. Do you see how this kicks out a positive? If I put a -3 into this problem right here, it kicks out a positive, and when I simplified it, it kicked out a negative. That can't happen. Remember, when you simplify, these two things are supposed to be equivalent. So to combat that, we put absolute value signs around that, and then you're going to get a -27, but the absolute value of that is a positive. So I hope that makes sense. If you have questions, make sure you see me tomorrow on that kind of thing. But it is when you have an even power outside for the root, an even root, and you pull out an odd, you've got to combat that by putting the absolute value symbols around that. All right, so that's why Embry has these absolute value symbols around here. You should be able to look through and see what they're doing on these types of questions. I'd like to get to where I'm actually doing them. You should be looking through those questions, though, Look through here, see how they changed it. Follow the steps. Sometimes they skip some steps, so you have to fill in the middle. But if you have any questions on what they did, make sure you see me tomorrow in class. We'll talk about the different scenarios. So here we go. Let's get to this part. They talk about why, these two are the same, Betty, and I think it's Wilma. It doesn't matter if you have this x in its own absolute value and the y in the own, or you could smash them together, but you have to make sure you have the absolute value because, again, this is a second power, and it's kicking out an odd power when you take that. That's x to the first power. So we had an even going to an odd. You've got to throw it around absolute values. All right, so here are some of the examples. So if I have the square root of 16, and then it is x to the 6th power. Again, what I've told you, what I do personally is I break this 16 down. And I break it down into its common factors. 8 times 2, 4 times 2, 2 times 2. So I really rewrite that as the square root of 2 to the 4th power, x to the 6th. Well, there's no number here, so I know this is a 2. That means I have to have 2 in order to pull 1 out. Well, when I pull a 2 out, I have 4 of them. So 2 goes into that 2 times. So I get 2 squared out, and there's no left over, so this is completely gone. 2 goes into 6 3 times, so I get x to the 3rd out. Okay? But since I have x to the 3rd out, this is completely gone. And remember, I went from an even to an odd, so I have to put my absolute value symbols around that. And 2 to the 2nd power, you always have to simplify. Whenever you can do math, you do it. So that's 4 x to the 3rd. And that's where they get this answer from. All right? Let's try something with a little bit more involved. So if I was doing f, so it says the square root of 81, and then x to the 5th, y to the 12th. Okay, and this is the 4th root. Okay, beautiful. First, I break down 81. 81, even though they're doing nice numbers for me today, it doesn't matter if this is an ugly number that doesn't have, doesn't pull completely out. So we'll practice hopefully that a little bit more tomorrow. But this becomes 9 and 9. 3 and 3. Remember, prime factors is what you're looking for because that's going to tell me what I can pull out and what has to stay inside. This is a fail-proof way. If you need more help on that tomorrow, make sure you see me about that, but you've got to break it down to its prime factors. That will tell you what you can pull out and what's going to stay inside. It's a much better way than the guess and check way that you were probably taught in Algebra 1. So if you need more help on that, remember, I write it down as its prime factors, and that just is 3 to the 4th power. X to the 5th, y to the 12th. Now, the reason I write it as prime factors is because I can see, oh, I've got 4 3s. And how many, if I have a 4th root, I need 4 of them in order to grab one out. Well, that means 4 goes into that 4 one time. So I get 3 out, and it's completely used up. 4 goes into 5 one time, so I get 1x out, but with 1 left over. So don't forget to leave that 1 in there. 4 goes into 12 3 times, so I get y to the 3rd out. This is an even one, and I'm pulling out the even ones that were in here to odds, so this has to go like that with my absolute values. And now this is completely gone. And then you cannot forget, you had an x that's still left over inside, so you have to have the 4th root of x still left over inside. And that is my final answer. Yes, I know that looks a little ugly, but that's what happens. With these ones down here, we have some options. If we have 3, the cube root of x plus 3 to the 9th. Remember, we can do this, I'm going to do this the other way. Yes, I think the easy way is to say it takes 3 in order to get 1 out. You've got 9 of these guys. So you have x plus 3. You have 9 of those. Well, how many times does 3 go into it? It goes into it 3 times. You do not need absolute value symbols. You do need these parentheses, or else that 3 would just belong to this 3. You do need those parentheses. You do not need absolute values because you started with an odd and you're going to an odd, so that's fine. We don't have to worry about combating the positive and negative numbers that can get screwed up there. Or the other way that we could talk about this is the final way, and then I'll be done with this video, is we said, hey, if you have this, you can change it into, because I want to practice that, you can change this into the power form, which would become 3, or x plus 3 to the 9th, and you would change this, oops, sorry, let me start over. Cube root x plus 3 all to the 9th power. Remember, you take x plus 3, what power is it 2 goes in the top? 9, over the power of the root goes out here, 3. And if you do that, you still end up with x plus 3, need those parentheses, to the 9 divided by 3 is 3rd power. Either way, you can change it from the root form into power form. This goes to the top, this goes to the bottom. You can do it that way, or you can think of it the way that I've been thinking of it up here. And again, remember, if you get a number, hopefully I can have time to do this. If you got a number like, they ask you for the cube root of 125. Let's do a weird number. I don't know if it'll work out. Let's do 110. If I was going to do the cube root of 110, I would take 110 and break it down. Okay? That's going to be 11 and 10. Nope, that's not going to work. Never mind. Let's try another one. Let's try another one. All right, so let's get crazy with it. Let's do like the cube root of 10,800. If I was just doing this, and then it doesn't matter about the x's. Hopefully that's making sense to you. But let's throw some x's in there just for fun. X to the 7th, y to the 2nd, z to the 10th. Something like that. I break this number down. So I take on my side paper and I go, okay, this big old number, let's break it down. Well, if I was breaking this down, I know that 1,000 is going to go into it, and 1,000 is going to go into it. 108. Sorry, not 1,000. 100. What am I doing? There we go. 100. I can break this down into a 10 times 10. I still break this down into a 2 times 5, and I break this down into a 2 times 5. Remember, break it down until you get to its prime factors. And if you notice, I circle them so that I remember them later on. 110, break it down, or 108, break it down. Divide it by 2, and if you divide it by 2, you get 54. So 2, that's prime. 54 is not. Break 54 down. When I break 54 down, I divide it by 9, and I get 6. Let's start with 108 over here again. We'll start with 100 over here. Let's get a lot of stuff up here. So, x to the, I don't remember what it was, but 5th, y to the 7th, z to the 10th. I think this was a 2. This was cube root. Alright, so this was, the factors there were 10 and 10, 2 and 5, 2 and 5, circle, 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 2 and 54, circle, 9 and 6, 3 and 3, circle, circle, 2 and 3. Now what I do is, you see there's a lot of stuff up here. So I go through and I start with my smallest number first, and I count how many there are. 2's, there's 1, 2, 3, 4 of them. So this would be 2 to the 4th power times 3. There's 1, 2, 3 of those. 4 of those? 4 of those? No, there's not 4 of those. There's 3 of those. My fault. My handwriting's getting me. And I'm trying to go quick because my next class is coming in. So there's 3 of these. That's a 5. And then there's 1, 2 5s. Now, how can I check myself? Is I can actually take 2 to the 4th, times it by 3 to the 3rd, times that by 5 to the 2nd. So really, this turns into 16 times 27 times 25, and if I put that in a calculator and I get this number, then I know I did my prime factors right. And then this is x to the 5th, y to the 2nd, 10 to the 10th. I don't know why it's 10. My brain is bad right now. Let's see. This variable's back there. All right. How many do I need to have in order to pull one out? You have to have 3 of them in order to pull one out. So I get to bring out a 2. But when I bring out a 2, there's 1 that's left over because 3 goes into that one time, but with 1 left over. 3 goes into 3 one time, so I get a 3 out. So this one, but they're completely gone. 3 goes into 2, it doesn't. So this 5 does not get to have anything brought out because it doesn't. This 3 doesn't go into it. 3 goes into 5 one time. So I get to bring 1x out, but there's 2 left over. So I cross this out and I put another 2 up there to remind myself. 3 doesn't go into 2, so no y's get to come out. 3 goes into 10 3 times with 1 left over. So I get a z to the 3rd out. And then inside here, I still have left in my cube root everything that's left over, which would be 5 squared, which is 25. 25 times 2 is 50. And then I would have x squared, y squared, z. And that would be my, and then I would turn this into a 6. And so this right here would be my final answer. Yes, I understand it looks ugly, but take your time, break your factors down. We'll practice tomorrow in class. If you have any questions, make sure you see me.